Welcome to solverfy.
Organic chemistry textbook. And this problem asks us, explain why the pKa of the carboxylic acid group of glycine is much lower than the pKa of the carboxylic acid of acetic acid. And we're given those values. So it's 2.35 for the glycine. So 2.35 versus 4.8. And in order to get the answer here, we need to look at what happens when we actually deprotonate each of these. So the glycine is going to look like this once it's deprotonated. And the acetic acid, when it's deprotonated, will look like this. Okay, and so basically, the reason that the carboxylic acid of glycine is so much more acidic than the carboxylic acid in acetic acid is because of the presence of this positively charged amine there, the ammonium ion. And the presence of that positive charge on that nitrogen is actually going to have an electron withdrawing effect. So some of the negative charge on the carboxylic acid in glycine is going to be withdrawn towards the nitrogen through the carbon. And so this serves to stabilize this conjugate base. And we should remember from acid-base stuff that the more stable the conjugate base, the stronger the acid. So stabilize conjugate base. So a more stable conjugate base is going to mean a stronger acid. And in the acetic acid here, there's nothing that exerts that effect. There's just a methyl group. And so this conjugate base is going to be less stable, and therefore, everything else being equal, this will be a weaker acid. And so that's the answer to this problem. The glycine has a conjugate base that is stabilized by the presence of that ammonium ion, the protonated amine with the positive charge. And the acetic acid does not have any corresponding stabilization effect. And therefore, the acetic acid is a weaker acid. And that's the answer to chapter 19, problem number 25.